Hi guys, my name's Doug. Welcome to my messy garage. Today we're going to be working on a electric bike battery. About a year and a half ago I built or modified a mountain bike that I had to use a electric conversion kit that I got from, I forget whether it was from AliExpress or from eBay or where exactly I got it from. Anyways, I installed the rear tire and mounted the motor, got the motor controller all working, purchased a battery mount kit and built the battery. And I used the bike a little bit on its initial charge. When I put the battery together, the cells were all fully charged, and I was very impressed with how well it worked. However, the first time I went to recharge it, which of course was when I was away on a trip, and needed the bicycle as campground transportation, the charge connection packed it in. You can see there's this wire here, used to be attached down on this connector. Connector burned off, acted like a fuse when I went to charge, and looking at it I can understand completely why it did that. Not the tab that it was attached to was not very strong, not very stout for the amount of power that was going to be going through it. So what I want to do today is take a RC airplane, car, whatever you want to use these for, connector, the XT60, and I want to mount it on a little pigtail that comes out of the battery so that I can use it for charging. And I figured I'd bring you guys along to check out this little mess and show you how the battery was put together and what we have to do to get it fixed. One thing we're going to have to be very careful of, this battery pack, I believe, if I remember correctly, is a 56 volt battery pack, and it does have some charge in it. So we're going to have to be careful that we don't accidentally short something out and start a fire. Less than ideal to be working with a charged battery. However, that's the situation we're in. So let me take this apart and I'll show you what we have. The battery case came from AliExpress, and I know that for sure because it took forever to arrive. The battery case itself has the cover, which I've taken off, this cell holder and the bottom plate, and then a piece that's attached to the bicycle that this slots into. Comes with a key that locks the battery in place. One thing I added, just as a bit of security, was the automotive style relay. All of the cells are reclaimed out of cellular modems. I got them from batteryhookups.com, and I'm in one of my other projects that I have on the go is building a power wall using Jehu Garcia's power boards, and I ordered in, I don't know, 100 or 200 cells and went through and tested them out. And the good ones went into the box that will go eventually end up in the power wall, and the ones that were less than ideal, basically I decided to put in the battery for the bicycle. And with a little bit of testing that I've done, I'm quite happy with how the bike performs with these cells, so I'm not terribly concerned that these are the weaker of the cells that I had. So we can see the cells start here, come up, bridge across, go back down, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in series, which at the 3.2 nominal voltage for these cells works out to be 56 volts, give or take. See, this wiring harness here is combination. One of it is the 12 volt power that provides the coil power for the relay. The rest of these wires are part of the BMS. Battery monitor circuit, which is in this board here, which monitors each cell and will adjust your charge and discharge rates. Here we have the pickup for the positive output. Here we have the pickup for the negative. So to get going on this, what we need to do, I have tape over that just to keep it from shorting out because it was all in pieces. We have our positive out, which comes off of the relay. We have our negative out, which comes off of the BMS board. This little pigtail went to a ground terminal here, which provided power back, or provided a route to ground back to here, which is the ground off of the solenoid. The advantage to the way this was all set up was that when you plugged in the charge terminal, it would open the ground circuit to the relay or solenoid, and therefore you could not charge and run at the same time. We're going to lose that functionality. Shouldn't be a big problem. The trick here will be to get a good solid ground and power lead back into the BMS for doing the charging. So let's continue on. This was our charge lead, which came up and attached to the primary output of the battery. And the negative lead charge came up to the negative lead of the BMS. What we can do here, we are going to have to provide a negative lead to the switch for the relay. So if I touch that down there, and I don't know whether the microphone is picking up that is indeed engaging. So that switch will need a ground, and then we will have to find a convenient way to get a charge ground back to the BMS. The other thing I want to do is I want to tape down this BMS a little better. I have some better Kapton tape kicking around rather than this little spindly stuff, and we will make use of it. Okay, let's get started on this project. So our first step is we're going to use a smallish step drill to drill a hole in the front cover of the battery housing. We're going to use some nice heavy silicone wire, which is what's used in RC cars and recommended for working on power panels, etc. And I am trying to convince my 3D printer to print off a protective cover that I will be able to use on this pigtail so that we don't have to worry about it shorting out against the frame of the bicycle or anything like that. You'll notice here that this is the male pins of the XT60, and there's not really a whole lot of protection. The female is a better connector to have sticking out. However, this is my charger, and you'll notice that it has a female plug on it also. So rather than risking having the male with the exposed pins attached to the bicycle where you're going down the road and hitting lots of bumps, that kind of thing, what I'm going to do is have a female out of the battery housing. I will make up a short male to male jumper, and then I will have the female on the charger. First things first, we need to drill a hole and put a grommet in that the wires will run through. think that's a good size drill bit. And looking at the battery itself, there are no cells immediately behind here, so there's 20 millimeters, 3/4 of an inch kind of thing, where we can use that for routing wires. So this is a good spot right here, reasonably close to center. Now I think we need to go a little bit bigger. Is looking promising. Okay, so there is our nice hole that we will route the wires through. I'm going to say, we only need 50 or 60 millimeters or 2 inches kind of thing. And when you are doing XT60 connectors, you can see on the side here, I don't know how that turns out, there's a positive, there's a negative. So we need those to go in. Fire up the soldering iron. We're going to need some heat shrink tubing to go over all of this. A nice piece of red. That black's a little snug. That should work. We're going to need a little bit more heat shrink tubing here. Okay, 3 pieces of red, 3 pieces of black, and what will shrink down and hopefully cover the entire plug. That will hopefully eliminate any possibility of shorting at 56 volts. Not that there's a huge amount of current in the charger, but at 56 volts out of this battery, you could probably get some pretty good lightning bolts going. Okay, so we got our soldering iron here. I don't know if everybody needs me to go into a great gory detail on how to solder, but ideally we want our soldering iron tip to be nice and clean. My soldering station at one time had a nice sponge, but it has long since disappeared, and I am left with a wet piece of paper towel that I use to keep my tip clean. Okay, so we'll slip the red back quite a ways, piece of black, again back quite a ways, because as I'm soldering this fairly heavy wire, it is probably going to put a fair amount of heat into the cable, and we really don't want. And what I find works well is you put it on here, put a little bit of solder, and that helps the heat wick from the iron and into the actual conductors. I want to get solder soaked into all of the conductors. So that they all make a good solid connection to the XT60. Now we take our XT60, which is going to be moderately difficult because it's got a little nub on the end of it. And we're going to want to tin up these cups at the end. Now we don't want to fill them because that will make getting the wire to lay in more of a challenge. But we do want them coated with solder. Now there's too much wire sticking out of the end here, and it is kind of balled up a little bit, so we'll take the snippers and the way that frayed when we snipped it tells us that we didn't get real good penetration. See how that was much more solid? It says that we got better penetration when we tinned the red than when we tinned the black. So, rinse and repeat. Yeah, that looks better. So, check, make sure we got the heat shrink on. I know we do. We got our negative terminal. I'm going to grab my simple pliers to hang on to that connector because we're going to be putting a fair amount of heat into it. I don't want to melt the plastic, but at the same time I don't want to melt my fingers either. Okay, so we confirm negative, negative. Got the soldering iron turned up as high as it will go. As I say, we are putting a fair amount of heat into this, and this is only a small, I think 25 watt or 20 watt soldering iron. I may have to get the soldering gun. I've got a nice heavy soldering gun out in the garage we won't need. Okay, we had a little hiccup with the memory card filling up on the camera. So I've got a few things done that didn't get recorded. We've got the female pin side attached to the battery housing. Heat shrink is inside, heat shrink on the outside. I made up a jumper that is male pin to male pin so that it works with the female pin on the charger. And plug that in, plug that in, and that keeps from having open pins that can short out against things. I am in the process of making a cap for this. Unfortunately, my 3D printer is being a little bit grumpy, but that will get done. So there, you're all caught up. So pull this back because we don't need a real big pigtail sticking out. Take a tie wrap. Put it around. Keep keeps that from pulling out. Now we've got the wires set up in the case. I will go grab the battery cells and bring it back, and we will figure out how we're going to do the connection there. This positive charge lead I don't want to use for charging purposes. I don't think it's heavy enough. I think what I'm going to do is route this positive cable over so that it attaches to the positive lead here. Now one thing we've got to be careful of, we don't want to put too much heat into the ends of these cells. Heat and lithium-ion batteries do not play well together. However, I think that is our best bet. And likewise, the ground lead is going to have to attach to the BMS. Now I need to decide how to best accomplish this. So that we've got enough slack that we can pull the battery back out of this case if needed, and likewise get at the BMS board. I think that should be enough. Now I don't believe we have to completely attach it, but it definitely needs a good attachment to that built-up solder section. Soldering iron and the solder, and again we want to keep the stringy solder away from the battery where we could have a short. And I guess that's showing up on the screen. Get a good amount. Oh, this is being difficult. Okay. So there we go. We've got the positive charge lead and the negative charge lead tinned up. So, flip the battery carefully up. And we will melt the charge lead onto the negative lead. I think I need to wet the negative lead out. Okay. There we go. Negative lead is attached. So the negative lead is attached. We're going to do the positive lead now. Without shorting anything out. And the positive lead up. Beside the existing positive lead, and we'll apply some heat. Okay, we've got two new leads attached. We've got our negative that goes into the BMS board, we've got our positive that goes into the positive lead. And now what I want to do is protect this battery a little bit better. I think we're done with the soldering iron for now. What I have here, it's called Kapton tape. This particular roll is for one of my 3D printers. They use this on the bed so that the 3D print sticks, but it is fantastic, both thermal and electrically inert. So let's put a roll of it down either side. Now, one other option for protecting a battery like this would be to use some large heat shrink. This heat shrink, I think, would be suitable if this was not going to be protected in a case, but I have a sneaking suspicion if we tried to put this on, it would add too much bulk to the battery pack itself, and we would end up having fit issues inside of this case. Now, we have what was originally our positive charge lead, needs to come out of there. And that is snipped off and underneath the insulation, so that should take care of that problem. Now, the one thing that we are left with that needs dealing with is we need to finish removing connectors from what was originally the charge port. And I think, given that it's broken, I'm just going to snip those off completely. Okay. So we've got the cells are back in the case. Things are reasonably well adjusted. One thing I don't like is that my pins here are exposed. So I think what I'm going to do is I'm going to desolder those off of the battery plate, and I am going to put some heat shrink down over them and then resolder them. Unfortunately, the little battery indicator, which I don't think really works all that well anyways, fortunately it is going to make the heat shrinking process a little bit of a challenge, but I would really like to see that done. So, since nobody else is going to do it for me, I guess I better get it figured out. Also, we've got the negative terminal that is going to provide the ground path for the relay. Needs to get soldered on as well. I'd really like heat shrink on those too. Hey, if we're going to heat shrink, we may as well heat shrink. Fortunately, thought I was done with the soldering iron and I turned it off, so it's cooled off a little bit on me. Is that showing up? Barely. Okay, we are soldered. Well, I think go on a little more. Now you might be asking the question, how come I required the big heavy wire for the charge terminal, but I'm using this little tiny wire on the relay? And the relay doesn't pull much power. It's very light duty. And the wire happens to be aircraft rated stuff, and it is good for up to 10 amps. And if the little coil in this relay is pulling more than 10 amps, then we've got bigger problems. So there, we'll slip those two pieces of heat shrink. And now, just for sanity check, the relay is clicking. Now we need some slightly larger heat shrink. There's a nice piece of red, a nice piece of black. That should work well for the main terminals. As we're to get heat shrink from, I think I've picked most of this stuff up. Some of the Harbor Freight store, although I can't speak to quality of their stuff. But other stores like that, or flea markets, quite often have, you know, a bundle of heat shrink for a couple of bucks, that kind of thing. Amazon.com would also likely sell it. But again, my channel's not monetized yet, and therefore I don't have any affiliate codes, so I'm not going to put any links at this time in the description. However, if in the future that situation changes, I may throw some links up on these older videos of the things that I have used while preparing. So if you're watching this in the future, by all means check below, there may be some links. Now, one problem we're having, and this isn't necessarily a permanent problem, but the wires that are on the indicator board are not overly long, and unfortunately, to be able to slide the heat shrink back, I need to extract this little board. Oh, it came out. Good stuff. Now what this board is, it's got a little button that you press on it when everything is turned on. That indicates the charge state. Now, as I say, I believe this battery is, for the most part, discharged, but that indicator still shows that it's fully charged. So how much good that indicator is going to be in the long run, I don't know. But the indicator is part of the case, so we may as well use it. Okay, I think we got a good solder connection there. Now let's desolder the positive. You'll notice that there are 4 posts here. It is possible that you could be running 4 wires instead of just a positive and negative. However, the other half of the case only uses the outer 2. The inner 2 conductors are not set up to be used for anything. So well, our red wire came off. We'll need to get that attached somehow. It can get soldered on when we're done. Ooh, I'm smelling hot plastic. That's not good. A little fresh solder on the end of that wire. Do the same thing with the connector, and we'll try this again. There we go, much better. Now we still have our indicator light. I think it needs a little touch of fresh solder too. Okay. Let's put a little bit of heat on that, shrink that tubing down. Okay, there's a little button in here. I don't know how well it's showing up, black on black, etc. We've got to make sure that that is in its place so that it presses on the little divot. That all looks like it should be functional. Now for the tricky part, sticking it all back inside the case. And you'll notice I just dropped a screw down inside. That would be concerning, other than the fact that I taped everything up. So now we don't have to worry quite as much. Now I don't remember exactly how this all fits down in here. I do recall that it was a little bit cranky about going in there. That little mounting tab I don't think is necessary. It is just taking up space and making things more challenging for mounting. So there, no more mounting tab. Now the trick here is we've got these 2 cells that are sticking up, and that is creating, there's not a whole lot of clearance between here and the top of the cells. I don't really want to pinch the wires in there if I can avoid it. You'll see I've clearanced one of the cell holders here to accept the wire. And I think we want to do the same thing up here. Clear that back out of the way. There we go. I think that's how it's supposed to be. In through there, in through there. That fits together better. We're still not perfect yet, but we're getting there. As I said, this is set up for 56 volts. The case would also work for 48 volt. And probably a 48 volt would fit in a little bit nicer. Likewise, when I was building the battery, if instead of putting those two cells on the top, I had put them on the front, that probably would have made fitting it all together just a little bit easier as well. But having it packed firmly inside is a good thing on a mobile product, because then it's not going to bounce around. So as long as there's enough slack in the wires that they are not going to pull out, I think having a nice tight fit is a good thing. So full battery. Let me go get my hilarious little Harbor Freight multimeter and we'll see what we've got for power. I'm curious if these leads are hot when the battery is not in use. And as I've said before, don't laugh at my Harbor Freight multimeter. The purpose of this basically is to test AA batteries, I'll be honest. I keep it in my battery drawer in my kitchen, and it's just a quick, simple one. Rather than going out to the garage and getting the better one, I'll just use this. So we go positive, negative, and we are showing 52.4 volts. And what do we have here? Positive and negative. And we have 52.4 volts. So, not ideal that this is hot, but not the end of the world. Plug that in. Red light tells me that we are charging. Let's unplug this and see what we have for in the way of voltage coming out of that.